Welcome to a code report solution video. In this video, we're going to be covering the solution to problem 1 from topcoder SRM 734 entitled TheRoundCityDiv2. The problem states John and Brew have found a nice horizontal plane and they built a round city somewhere on the plane. The center of the city is at coordinates 0, 0. This point is left empty. There is a house at each other lattice point that is at most r units away from the city center. That is, the lattice point xy other than 0, 0 contains a house if and only if the square root of x squared plus y squared is less than or equal to r. John and Brew now want to count all the houses in the city. You are given r. Return the number of houses, and note that r will be between 1 and 100 inclusive. So let's take a look at what this problem is asking. So basically we're given a horizontal plane and the blue dot represents the middle of our city. So our city center at the coordinates 0, 0. And we're going to be given an r that's going to be between 1 and 100, and this r represents the radius of our circular city. And the question is asking how many lattice points, so these sort of intersections of the horizontal and vertical lines, lie in or on the boundaries of our city. And so for r equal to 1, we're going to end up with 4 houses. So the red circles are representing each one of our houses. And note that there is not a house at the coordinates 0, 0. So if we change r from 1 to 2, we'll have a city that looks like this, and then we will have an additional 8 houses on top of the original 4 when r was equal to 1. So the total number of houses for r equal to 2 is going to be 12. And so if we change r from 2 to 3, it'll look like this. And once again, we will have an additional 16 houses, giving us 28 houses in total. So the question's asking, given r, how many houses are we going to have? So the algorithm that we are going to use is going to be very simple. We can brute force check each pair of coordinates to see whether or not they lie in our circle, because we know that at most radius is going to be 100, which means that for a quadratic algorithm of checking each pair of points, it will easily run in the time limit given. So we're just going to check each of the pair of coordinates for the square surrounding our circle. So we'll loop from negative r to r for both I and j, and then check is the square root of I squared plus j squared less than or equal to r, and if it is, then we will just do a post increment on our count, as it means that we have found a house in our circle. So let's take a look at our code. So here we have a pretty simple function. It's called find. It returns an integer, which is the number of houses, and it takes one parameter, an integer r, which represents the radius of our city. So at the top here, we're declaring the integer c, which is going to be the count of our houses, and we're initializing it to -1 because we don't want to count the house that we would find at the coordinates 0, 0. Then we just have a nested for loop for our indices I and j, and they are both looping from -r to r. And we are checking for each one of these coordinates or pair of indices if the square root of I times I plus j times j is less than or equal to r, then do a post increment on the count of our houses c. And once we finish this nested for loop, we can just return c. So the last thing to talk about is the time complexity of this problem, which was stated previously, and that is quadratic in the size of r.
As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.